So hello everyone, this is Ascent Fabrication's Fabrication Friday. Joe Fairley here, and I have a special guest today in Richard Miltenberger from Macuris. In the past we have kind of gone through, a little bit in depth in terms of what hardware and softwares are out there for 3D scanning, 3D printing, and then some of the modification software that we can use, but we haven't really, dived deep yet into any of these modification softwares. So we went through a brief overview a couple episodes ago on, what 3D scanners we suggest here at Ascent Fab, and looking towards, what's the easiest to use, probably hopefully lower cost, and something that's going to be detailed and accurate for us. We looked at, the different type of 3D printers that are out there in terms of the hobbyist level, more industrial FDM type 3D printers for the fields right now, and then looking on into more industrial 3D printing for, say, HPMJF or SLS. So that was kind of a nice brief overview, but today I wanted to kind of bring in Richard. Richard and I met yesterday, getting more feedback from him, and starting to work together on some projects for Macuris. So, Richard, if you'd like to introduce yourself and kind of what your role is at Macuris.
Great, thanks for having me. My pleasure to be here today. Having just met you recently, excited to be on, and cool to see the workshop behind you as we talk. So that's pretty cool. So I am a CPO. Been in the field since 2008 and been in many different parts of the industry, working with Department of Defense several years, and private practice, some research and development, some research studies during my time at the Navy, and most recently digital design. But I've always had kind of the curiosity to expand into digital design, and so joining with Macuris in this venture has been pretty exciting for me. So I am one of the CPOs at Macuris, and the customer service expert point of contact here in the USA as we kind of move more into the US market, just providing awareness and customer service. And really, my skill set is, taking what might be difficult and bringing it down to wherever you are. And so we all come into this with different levels of skill. I am not a CAD techie genius. I'm a CPO, and I really love plaster. But when I was working for the Navy, I gave myself some carpal tunnel and a pretty bad back hunch, spending about 5 hours a day in the plaster room. So I know what it's like to kind of feel that pain and like what else is out there. It's kind of fun to be in this arena and share what I know and kind of bridge the gap for people. So, people send me questions all the time. How does this function? How do I do this? I do this in plaster. How do I do it in CAD? And so at Macuris, we have what is a very flexible, intuitive platform and pretty easy to get into. So it's been pretty fun to learn and pretty fun to teach.
Yeah, you have a couple good points there where, we're so used to doing everything by plaster. Maybe in the past there's been some hybrid model of maybe doing some plaster modifications, then scanning a plaster mold, right? But that, in the past, maybe up until about 2-3 years ago, that was kind of the extent of, the digital workflow for some people. Even if some of these modification softwares have been around for a little while now.
Mm-hmm.
Kind of take us through maybe more of any clinical experience that you have with any other softwares, if you do. If some of the softwares that have been around for a while, Vorum, Rodin 4D, Oster Design Studio, formerly Standard Cyborg. Have you had any experience with those, or Ohio Wellwood's Omega or TracerCAD?
Yeah, less experience with Omega, but I've been in Vorum, Rodin, and more of Design Studio before it became the Oster product. So yeah, very familiar with those, and kind of like you said the other day, like software. I mean, it's a bit of a personal taste too. So a lot of these programs are super powerful and have a really big toolbox. But that because of that, they can be super daunting. So, but yeah, I kind of got started with SolidWorks and got trained in SolidWorks, but realized that this is not applicable to the kind of mesh environment as well, and the organic shapes, and but there's been a lot of other pioneers in that area for what kind of software to use. Mesh Mixer is great, free program, and these softwares like Vorum, they have really so many tools and capabilities. But some of the things that I'm hearing from practitioners are like, it's kind of daunting. Maybe it's like too much at once to learn, and so I think there's been, CAD's been around for a long time.
Yeah.
It's not like this is 2022 and all of a sudden we can design in computers. But we are getting to this point where there's a tipping point. More people are interested just because of the general pressure of practice and trying to be more efficient. So, jumping in from other softwares into Mercurius, I found it to be very intuitive and simple. I dropped a video this morning on how I modified an AFO in 7 minutes, and that included correcting an ankle plantar flexion of like 15 degrees automatically. So some of this software, and that's one feature of Mercurius that's very cool, is the adjustability of the scan. So if you have some weird stuff with the scan, you can create a skeletal structure and correct your ankle and foot position. But
that feature I think has been pretty unique in terms of being able to modify the angle of a certain scan after the scan has been taken, to a degree that it doesn't directly affect the scan itself. If I try to do that same thing in Mesh Mixer, we're going to get a completely distorted result, right? So that was something that I've seen from Mercurius that was a nice, unique offering there. So has that been something that you think the clinicians have been taking advantage of so far?
I think so, and it's the videos we show are pretty extreme corrections, but most of us take a cast and we're like, if I'd only pitch the forefoot a little bit, it'd be better. And so we end up cutting the cast and gluing it and all that. So I think it's helpful in that area, where if you just want to kind of drop that big toe to the ground or correct a couple degrees of plantar flexion, it's going to be super useful. And it's one of those tools that I wasn't sure about when I first saw it, but then when I started using it, realized, oh, okay, this is something I'm going to use all the time. Yeah, I mean, cool.
Yeah, no, definitely. I thought that was a nice, addition to, the modification tools that we've seen, primarily in some of these softwares. So that could definitely be useful for some people if they're scanning directly over a patient's limb, whether it's maybe prosthetics or orthotics. That could be fairly useful. If they've taken that cast, then they can do that correction in CAD rather than doing the wedging and stapling back of the cast itself. So that's pretty unique. You talked about kind of some of those pain points of clinicians being overwhelmed or daunting for maybe some of these more engineering, CAD heavy softwares. Can you speak to kind of what some of those pain points might be for some people and how, you think Mercurus is doing that differently?
Oh yeah, I think well, from personal experience, I always am interested in new software, and so whether it's like a video editing software or like a CAD program, you get this idea in your head, and I'm like, I got to get it on paper. Well, then you download the program, and you go in there, and it's like I'm in this big empty room, and it's like, oh, what do I do? I've got to actually build something in here, and
Right.
how do I do that? And then I think you get kind of CAD fatigue, and then you just like, oh my gosh, I don't have time for this. And I've done that several times, and I think that's a lot of people's experience. And so what we try to avoid with Mercurus, we have a lot of support available within the program. So like any page you're on, you can just click the video icon and like up pop all the how-tos on every tool. It's like a couple
That's
minutes on
nice.
every tool. We also have like an e-learning program where you can sign up and you get modules sent to you, and they're like an hour each.
Okay.
If you really want to get into it. And that's really nice to start out because it gives you kind of a baseline. And you can take your scan and work on it through the steps. We also have in every module a test scan available. So I think one sticking point for people is like, I don't have a scanner yet, and I don't know how this is going to work. And I don't want to buy a scanner and find out that I don't like it.
Yeah.
So you could just pull in a test scan and start playing around with it right away. So there's little things like that. And then not to mention that our toolbox is a little bit smaller, still very powerful, but it's just more kind of condensed in that you might not have it's not like 1,000 tools in there. It's like we have like 12, and then you just use them in the right sequence. And once you learn the patterns, it makes a lot of sense.
Yeah. So that sequence of kind of how you're using those tools, I'm sure is, probably outlined in those videos. Does it kind of prompt you as you go along the modifications as well?
No. So what we're doing is, there's not any automation. It's really a workbench transfer. So, we're probably working on more like that. That's why we're posting videos on. Here's the sequence. Like, here's how to modify an AFO like 3 different ways, because you might do it a little bit differently than I do it, even in plaster. You might be really measurement focused. I'm very visual focused.
Right.
I like to look at how it looks. I like make it look like a leg.
Right.
But some people are very measurement
for some
focused.
People to do, and just looking at something in the 3D space. They
right. You don't know. It could be this big or it could be that big. And it does take it takes practice. And it's like we tell everybody with webinars and stuff, this is something that the software doesn't implement itself. Just like a 3D printer doesn't implement itself. It's like you can't buy it and then it just tells you how it works. But we're trying to make it as easy as possible. So we will be putting out more and more content. And I think with our learning platforms, it's more like you run into a sticking point, watch the video. Okay, that's how you do it. But there's no there's no paperclip popping up and saying, hey, I see, you're doing an AFO.
Right. Yeah, no, it's nice to see too, kind of that freedom of being able to play around with it kind of before you get started. It's nice that the software is, somewhat free to get started, and try to start messing around with some demo models, because I know, again, that's primarily just people getting used to translating their plaster modifications to the digital space. Is from what I see from my customers, that connection takes a little bit of time, but within, say it's a prosthesis, maybe 2 to 3 test sockets that I go through that workflow with them, they start to get the hang of it, and we start speaking the same lingo pretty quickly. So I feel like right now with this huge push of people trying to be more efficient, and, wanting to decrease the amount of time they're taking with fabrication and modifications, there's definitely a space for, different softwares to, meet the needs of different clinicians, right? Every clinician might not be great with Mercurius, and Mercurius might not be a great solution for their clinic, but, there might be other softwares out there that are very, driven toward the devices that they do, right? There's different clinics that specialize in different devices. So, there's that kind of, that little hump to get over for the clinician to see, okay, I can translate my plaster mods to this digital space, but then, the devices that I'm making too, does it make sense for me to use, software X, Y, or Z? Or scanner X, Y, or Z, or 3D printer X, Y, or Z, right?
Yeah, and it's like you say, everyone has to come up with their own methods. I mean, that's kind of how it's been in our field forever. Not a lot of standardization. And so just like when you try a new technique, if you switch from plaster to fiberglass, you're gonna notice changes. Oh, I don't have to reduce as much. I don't have to modify as much necessarily. Like it changes your whole thing, and you might do it wrong a couple of times, but then you get the hang of it and you realize, oh, well, actually a little bit less work. So I feel like it's the same with digital. You have to practice, and I wouldn't recommend practicing on someone you don't know. Find one of your trustworthy test patients who loves you, and then and try it out and do it side by side the other way you do it, and see what the differences are, and do that a couple times, just like if you were training a resident. When I train a resident, I always take a cast and then have them take a cast, and then we fit them together. And so you kind of have to do the same thing.
Right. Yeah. I couldn't agree more. I mean, for some of the new devices that are being 3D printed as well, we don't quite know the longevity of them or the cyclic nature of how long they might last. So that's kind of the same workflow I would go through with a patient to make sure that the devices that we're making are, safe for the patient, first and foremost, and hopefully a little bit better, function wise. Or decreasing turnaround time to get a fitting, or just kind of offloading some of the physical workflow of what we have to go through as clinicians. So, I've seen that's very powerful right now with getting into the digital space, is being able to think about how we're designing the devices as well, trying to go forward with standardization and, maybe having some clinical modification standards even, maybe through digital, we're able to create workflows that work for a specific group of patients. If it's the typical diabetic or vascular BK patient, that we have maybe a known workflow in some digital sense that would get us to a repeatable result every time. Hopefully maybe that would help lift the bar in some ways for clinicians.
Yeah, I think, well, obviously it depends on the skill of whoever's using the tool. And we've all had failures with traditional methods. I mean, I've had plenty of head scratchers, and so I'm not gonna blame that on the plaster or the digital necessarily. Now, but you got to try it a few times and make sure that it's working for you. But yeah, those are, I feel like the added benefits, we don't even know the extent of them yet, because none of us have like a library of STLs to swap and change and compare one to the next. Some people do, but not as many. So I just think, yeah, you're right. I mean, it'd be easier to standardize for sure, and to teach without a low risk teaching method, to get people acquainted with even a plaster environment. So yeah, it's pretty neat to see what's happening.
Yeah, definitely. You mentioned the teaching aspect again too. I just wanted to highlight for people watching here that um, back about maybe 2 months ago, went through a project with UT Southwestern, which was a great introduction for some of the students there in the master's program, where they went through scanning for a solid ankle AFO. Kind of the same workflow we would go through if we're going to be casting, putting markings on their limbs and taking a 3D scan with comb and then uploading it to the Makira software where they, did their clinical modifications that they thought were appropriate and creating those solid ankle AFOs to then be fabricated here at Ascent Fab by our FDM machines in polypropylene, and also comparing half of them to SLS PA11 made AFOs. And so that was a great project to go through there with the crew at UT Southwestern, and just gave me a first introduction towards seeing some of the devices that could be made with Macuris.
Nice. Yeah, that's pretty great.
Yeah, yeah. So that's something I think too, in the Makira software that's slightly unique in some ways, is that you can actually create the device in there, right?
Right, right. And we didn't even talk about that. So there we have the third module is like a creator software where you can go in, and currently it's for upper limb, or we don't have prosthetic creator in there yet, but it's orthotics.
Okay.
So you can create an AFO, KFO, hand or elbow, and there's a lot of room within that to experiment. But yeah, it creates the shell, and then you can create cutouts and holes and slots and patterns and things. And it's pretty, it's not telling you how to do it. It's not, you're not dragging it and dropping it on there. You have to learn kind of how to create the trim lines and everything. Right. But you have this total freedom. And that's kind of what's cool is, you can at any point download your file. Mm-hmm. If you want to download it from the modeler and carve it, that's totally fine. If you want to move it to the creator and then try a print, send it to Ascent, you can do that. Or, we have people printing the positive model and then like doing pre-preg over that. So there's all kinds of hybrid. Yeah.
So that's definitely nice to see right now. And we have this, hybrid nature already, which I don't think will ever go away and completely go only digital, right? I think there's always going to be a mix of, traditional fab with digital fab, but, I was thinking through, how we could, again, steer clinicians into what might be a better device, a better end device over something else that they might create. Because one thing I noticed was just in terms of the thickness of the AFO, some students did a thicker or thinner AFO, and that did affect, some of the printing properties, how I had to print it. Which, some of the surface quality wasn't as great in some thin areas. So having a inconsistent thickness, is something to consider when you're going for specifically FDM printing and worrying about, the surface quality. But
right.
Everything else that was more of a consistent thickness throughout and between 4 to 5 millimeters was, a really nice looking AFO at the end of the day. They all came out really well. I thought, with some minor abilities to grind and buff the edges, just like you would with regular polypro. The SLS PA11, they were able to grind and buff those similarly, but you can't heat modify, the SLS or HPMJF PA11, PA12 nylon devices really after the fact. So that's what's nice too about polypropylene is that, we can end up, making those heat modifications again, if necessary, Yeah, that material we used there was from PP Print out of Germany as well, Macuris out of Germany. So, I just thought that was some cool things to kind of highlight from that experience.
That's awesome. Yeah, that the polypropylene you showed me was pretty impressive looking. Um, so that's kind of exciting as we see more filaments coming in that are useful. Also, I think what a lot of clinicians see the benefit of is the final device and the improvements you can make, or the kind of limitless construction abilities that, whereas before you had to think, this is going to take too long, or
Yeah.
now it's like, well, you can try it and then try it again if it doesn't work quite right. And you have the opportunity to do different durometers, like your foam flex inners, which
Yep.
um,
Yep.
I mean, that's a big improvement, like targeted compression and targeted relief, and
Yeah.
so
Absolutely.
that's kind of stuff people are getting excited about, I think.
Yeah. For anyone who hasn't seen one of the SMO designs that I did previously, this was not designed in Macuris, but maybe we'll go through that next as a next project. But that was the polypropylene shell from PP Print. Kind of a nice shiny finish there on the screen, but you can see some of the motion. I've been going back and forth with this foot plate now for a couple months and haven't seen any cracks, so that's nice. And then, like Richard said too, our foam flex, inner boot, we could end up having, hopefully maybe designed in Macuris as well. Some cushioned areas over bony anatomy, where we could actually possibly, not have a need for, extra padding in those areas. So, for me as a clinician, trying to clean up an old AFO and put on more padding was, just something that I didn't really enjoy going through. But, getting rid of all that glue, scraping off and grinding and just getting it all over the place, and it's already, mucked up and, compressed out. We haven't seen the foam flex, cushions compress out over the last 10 months. So that's been really nice too.
Cool.
So yeah, there's definitely a lot of
and your
things we get
patient could order a new one.
Yeah, no, with
right. I mean,
retrofitting the exact same design, right? If we could even potentially, for pediatric cases, maybe we end up having extra shells, or if we need to make little adjustments around bony anatomy, maybe we start out with a thicker cushion in that area and then slowly get a little bit smaller that we can still, retrofit into a device to hopefully, increase the longevity of that device.
Nice.
Yeah.
That's pretty cool.
Yeah. So that kind of onion effect, would be pretty neat to look at, and how we can retrofit devices with, with that 3D design. But yeah, no, I'm excited about, testing out the Macuris software here and getting a sense of, its capabilities for, not only lower limb orthotics, but hopefully, prosthetics here as well. You said you guys were in the middle of starting to develop better workflows for that too.
Yeah, so currently you can pull a file in and use all the tools there. We're working on some features in the pipeline that'll make that a lot easier and more like your traditional workflow. But if anyone has questions, they can always book a meeting with me, and I can walk you through kind of where it is right now.
Yeah.
So yeah, you can pull in any file and work with it. I've just, you can create random shapes if you want. It's kind of fun. So yeah.
I'll
but yeah, we're
definitely mess with it here over the weekend a little bit and next week. And I look forward to kind of working with you guys a little bit more to, again, test out some devices that could be printed, and see some different capabilities. If somebody was to, look into Macuris, how would they get in contact with you and Macuris to get a demo?
Yeah, absolutely. So you can you can find me on LinkedIn, Richard Miltenberger, or Mercuris, Mecuris. Not Mercury. It's Mercuris. So it's mercuris.com. Make sure you click on the English website if it comes up in German. You just hit the little American flag over on the side, and you can create an account for free. You get 5 downloads a month, and it's the whole software. We're not restricting anything at this point, so you can use all the tools. And 5 downloads a month is plenty to start learning. And you can start learning without doing any downloads. You can just go practice without downloading anything. So
Yeah.
it's very easy to sign up. You just give your email, you get an account created. You can also sign up for the video library and like the e-learning. But yeah, on there you can book a meeting, or you can also email me rm@mercuris.com. And
sounds great.
Or if all that's too complicated, call Joe and he'll let you know.
Yeah, no, I'll definitely post some of that information here in the notes on this episode. And yeah, thanks again, Richard, for kind of giving us a good overview. Yeah.
Thanks for having me.
Yeah. So happy Fabrication Friday, everyone. Look forward to working with Mercuris a little bit more here to see what we can come up with for devices. If you're already using their software, great. Reach out to Ascent Fab to see if what device you're looking to 3D print can be 3D printed with some of our machines and materials. And we'll definitely go through a kind of troubleshooting phase initially with you to see, like Richard said before, have a good patient in mind. That would give you good feedback. But also make sure they have a backup device too, so that we can really, ensure patient safety here with, looking toward, testing devices like this where we don't have any cyclic data or other, long-term patient data yet. So I'll definitely post some information about Mercuris here in the notes. And thanks again, guys. we'll expand upon our software endeavors here as weeks go on. So thanks again, Richard. We appreciate it.
Thank you, Joe.